Have you ever wondered what actually happens when a company gets hit with a cyber attack? Behind the scenes, it's not just chaos and panic. It's actually a super coordinated race against the clock. Today, we're going to pull back that curtain and walk through the entire incident lifecycle, from that first flashing red light all the way to the lessons learned at the very end. Let's jump in.
So, picture this. You're a security analyst, you're sipping your coffee, and then bam, this message flashes across your screen, a critical alert. This is that moment, right? The starting pistol has just gone off. So, what's the very first thing you do? Where do you even start? Well, before anyone can respond to anything, something has to spot the problem in the first place. That's the job of an intrusion detection system, or an IDS. You can think of these as the digital watchdogs for a network, and they are always on the lookout for any sign of trouble.
Now, these digital watchdogs, they come in two main flavors. First, you've got a host-based IDS, or HIDS. This is like having a security guard posted inside a specific building. It watches every single thing happening on one computer. And then you have a network-based IDS, or NIDS. This is more like having security cameras watching all the roads leading into town. It monitors all the traffic flowing across the entire network.
So how do these systems actually spot an intruder? Well, they use two main techniques. Signature-based detection is kind of like a bouncer with a photo book of known troublemakers. It's looking for patterns or signatures of threats we already know about. It's really good at that, but it can't spot a new face in the crowd. On the other hand, you have anomaly-based detection. This is smarter. It learns what's normal for the network, and it flags anything that looks weird or out of place. This is awesome because it can catch brand new attacks, so-called 0 days, but it can also be a little paranoid and sometimes raise a false alarm.
Okay, so an alert has fired, but here's the thing. Not all alerts are created equal. Security teams get flooded with hundreds, sometimes thousands of these every single day. So the next critical step is to sort through all that noise to find the real emergencies. This whole process, it's called triage.
Triage is all about one thing: prioritization. It's the system that makes sure the really big, scary issues, the ones that could sink the ship, get looked at right now, while the smaller stuff can wait in line. It's all about using your time and people wisely when the pressure is really on.
And this whole process really just boils down to 3 key steps. First, an analyst gets the alert and has to figure out, is this a real fire or just someone burning toast? Is it a real threat or a false positive? Second, they assign it a priority level based on how much damage it could do. And third, they start grabbing the initial clues and evidence to figure out what's actually happening.
So, how do they decide if something is a top priority? Well, they're asking 3 absolutely critical questions. First, functional impact. Is this going to stop us from actually doing business? Second, informational impact. Is our customer data or our secret sauce about to be stolen? And third, recoverability. How hard and how expensive is it going to be to clean up this mess? The answers to these questions pretty much determine how fast everybody needs to start running.
All right, the incident has been prioritized. It's a big one. Now the deep dive investigation begins. This is where analysts turn into digital detectives, and their #1 source of clues is what we call logs. They have to follow this trail of digital breadcrumbs that the attacker left behind.
See, every single action on a network, someone logging in, opening a file, anything, it creates a log entry. Think of each one like a single digital footprint. By itself, one footprint might not mean much, but when you piece them all together, they start to tell a story of exactly what happened, when it happened, and who did it.
Now, this is where it gets a little complicated, because these logs, they come in all sorts of different languages. For instance, you'll see a lot of JSON, which is super common in web applications. It uses these really simple human-readable key-value pairs. You can see alert is malware, severity is 10. Pretty straightforward.
But then you'll run into something totally different, like syslog. This is a classic standard, and it's much more compact, a little more dense. It has its own unique structure that's completely different from the JSON we just looked at.
And then there's XML, which you'll find all over the place in Windows environments, using these structured tags. Now, the key takeaway here isn't the specific syntax, it's the sheer variety. You've got data pouring in from thousands of devices, and they're all speaking a different language.
So with all these different log languages flying around, how does anybody possibly make sense of all that noise? Well, that is the magic of a SIEM. Think of a SIEM as a universal translator and the central command center for security. It collects everything from everywhere, it normalizes it all into one common language, and then it lets analysts search across the entire organization to connect all the dots. Seriously, without a SIEM, modern security would be impossible.
Okay, So while the security team is in the weeds, investigating the how and the why of the attack, there's a whole other team focused on a different, but just as critical question. How do we keep the lights on and keep the business running through this whole crisis?
And this is exactly where the Business Continuity Plan, or BCP, comes into play. This is the playbook. It's the master plan for how a company is going to keep its essential functions up and running during a major problem. And that could be a cyber attack, a hurricane, you name it.
Now, a lot of people get BCP and a Disaster Recovery Plan, or DRP, confused. But there's a really simple way to think about it. The Business Continuity Plan is all about the business, the people, and the processes. The Disaster Recovery Plan is purely about the tech, getting the servers, the data, and the networks back online. One's about process, one's about plugs.
A big part of that planning involves backup locations. At the top, you have a hot site. This is a perfect mirror image of your main office, ready to take over in an instant. Then there's a warm site, which has all the equipment but needs a little bit of setup to go live. And finally, you have a cold site, which is basically just an empty room with power and internet. It's cheap, but it'll take you a long time to get it up and running.
Okay, the threat is contained, the systems are restored, the business is getting back to normal. So we're done, right? Not even close. Now comes one of the absolute most important phases of the entire life cycle, learning from what just happened.
After any big incident, the team gets together for what's called a lessons learned meeting, or a postmortem. And there is one golden rule: no pointing fingers. The entire goal is not to find someone to blame, but to figure out what went wrong so the organization can improve and be stronger next time. And during this meeting, they dissect the whole incident. They build a precise timeline of exactly what happened and when. They review every action taken. And most importantly, they ask that critical question: what could we have done differently? This is where the real learning happens. This is how you get better. All of these findings get compiled into one final report. It's got a quick summary up top for the executives, a minute-by-minute timeline, a deep dive into the investigation, and, crucially, a list of concrete, actionable recommendations to make sure this doesn't happen again. This document becomes part of the company's permanent memory.
So, the report is filed. The ticket is closed. The life cycle for this one specific incident is officially over. But those recommendations, they feed right back into the beginning of the cycle, creating new policies, buying new tools, and training people. It prepares the organization for the next inevitable alert. Which kind of leaves us with one final thought, doesn't it? Is the work of securing an organization ever really truly done?